later and try to find your way on how to use it. I think I remember I had a handout on how to use it step by step. I'll try to find it and send it to you. And I would like you to upload the code you wrote for this one later and put it in. Now, let's check out how we can do the code for this part. For this part, as you can see, we have the just small square shifted aside on the top of the larger cube. The process is going to be very simple. We're only going to do the offset of the square and by the radius of the cutting tool. Definitely, we are going to have one square, then one line. So the cutting is going to be very easy. It's one square and one line to remove the rest of the top. The problem we have is that the depth of the cut is 10 millimeter. You remember that if this part is made of any material, we cannot get the depth directly to 10 millimeter because this will either going to damage the tool if the part is hard, or it's going to damage the part if it's not hard. That's mean if this one is made of, for example, let's say foam, like the one we used to use in the lab before. If I'm going to insert the cutting tool inside the foam by 10 millimeters, start to move it, it's going to damage it. So we need always to remove the material layer by layer by layer until we're going to reach the final depth. So I think that Lisa said that she already wrote down the code for this one, right? Lisa, you said that? Lisa? Maybe she cannot hear me. I think that Lucas was asking me a question about how much it costs. $45, Lucas. Yep. So we have to do it, let's say, 3 millimeter each time by rough cutting, and then the last cut of 1 millimeter layer, the last one is going to be removed by what we call the finish cutting. And when we are going to finish with that, we are going to do the drilling for it. So just a simple code. Everyone can write it down, and then we are going to upload it. Put it in any simulator. The simulator that Carlo, you remember Carlo, the guy who was working in the lab before, he always recommended to use this one. It's called a CNC Simulator Pro. CNC Simulator Pro. What we like with this CNC Simulator Pro is going to show you the environment of the machining. It's going to be something like you are in the actual place. Try to download the, yeah, I think they have a demo version, and it's going to work for 1 month. Download it, use it for 1 month. And I prefer that you will keep it for the subject of the advanced manufacturing. That's why actually I'm not going to ask you to do it now. We're going to do it for the advanced manufacturing, and we're going to try to add it as a part of our assignment number 1 work. So instead of that, I will try to use today to show you something about the CAD/CAM, or how to generate the code for more complex shapes by using the SolidCAM. So I think Solomon told me that he already downloaded the new panel, the what they call it, the
Citrix.
Yeah, the Citrix. Lisa, have you got the Citrix? Lucas?
Not yet.
Okay, let's do it now. Actually, it's not going to take more than
I don't
5
believe
minutes.
I don't believe I have it. I don't have my laptop with me right now. I'm watching this on my phone.
Okay. So you can check the recording later, and I will go in step by step on how to sketch a part and how to use the SolidCAM in the work. Now, even Lisa, you don't have to install anything now. You don't have to follow me at the moment. Watch the video later, and then we will be able to, you are going to be able to actually do it again. So the first thing I'm going to do is I'm going to unshare my screen, because one of the problem I have is that the SolidWorks doesn't work when I get to use a double screens. The option I'm going to make is again to make this thing working on both screens. Sorry, to make the my screen duplicated on both screens. So actually, that's what we going to do. I'm going to share the screen now, and I'm going to start with using the Citrix and working on it. Okay, now that's my screen. That's what we can see, and I added somewhere here. The only thing that I told you about earlier that is going to be black. I didn't follow the steps you told me about, Solomon. I'm going to do it soon. Anyway, it's going to start, and we are going to log into it like we do with the VMware. I think it does have some disadvantages, but the main advantage I found with this software is it's easy to deal with if you have any problem. So you can stop the software. Again, to turn off the camera, we don't need now. Okay, you can stop the software if it's going to be freezing, and also if you have any problem with the sharing of the file with the how to store to manage the storage on your computer is going to be much easier to be managed in the in this software rather than what we had in the VMware that I usually have to define it every time. I don't know why it doesn't work right now. Let's try to do it from the or maybe it's working behind. No, not yet. Oh yeah, it's here. Yeah,
yeah, it's
I
a black
think
screen for us.
you can see black, right? How you can see it?
That
Is
is
it black?
correct. It's black.
Yeah. Okay. Anyway, so what you can see is black. Well, anyway, what I have right now is the UTS page and ask me to put the username and the password. So again, to log in first. And again, Solomon told me how to fix it, but I need to install the thing and install it once again. I get to do that maybe tonight to solve the problem. So again, to show you it later, another tutorial with the thing showing better than that. edu.au. Oh, I think I put comma instead of dot. I'm going to change that. Enter my password. By the way, can you hear any sound in the back? Well, I know I may ask you this question before, but I want to check that if I put my money in a good investment. As yesterday,
I haven't heard any cars so far.
no car. No, I asked my wife to talk and check if you can hear or not. Can you hear any knock?
No. How much did that cost you?
No, that cannot hear it. Yeah. So yeah, because I bought this software that I was trying earlier, and actually they give me a good offer, $5 per month, which is not that bad. Yeah, and I think you can still see the black, but I think that when again to turn on the SolidWorks, you should see the SolidWorks. So I will start with the SolidWorks, but we have another software. I will ask the student to use it in the in this subject, which is called the NX. And NX is a software from Siemens. You know that SolidWorks is from Dassault, which is a French company. Actually, they are the company who making, if you ever heard about an aircraft called Mirage, they're making the Mirage. And the other one is from Siemens. Okay, so I'm starting the SolidWorks and I accept the license. And can you see the startup of the SolidWorks, or this one also cannot be
Yeah,
shown?
I can see the startup.
Okay, that's good. That's good. Okay, so we start with the thing. So you can see that the shapes I'm doing right here is the one I used previously in this subject for the CAD CAM. This was the part we used last year for the CAD CAM. It's have a spherical shape here. Actually, I get to open this one. So I'm not going to do it right now, but I'm going to show you this shape and the idea I got from this shape, which was this spherical shape at the top, and this will allow the student to think much more. Maybe it was saved in another directly. Anyway, I'm not going to do it, so I get to make a new one and start with it. So I'm going to make very simple shape. Well, I think it's going to be simple, as you can see. But the most important thing is just to show you how we should start to sketch a part if we would like to do it for the CAD/CAM operation. Now you remember that in the CAD/CAM, we were always talking about the X horizontally and the Y vertically. So what we're going to sketch a part, and we're going to do the machining of this one by using something called the SolidCAM, which is available right here. We need to work on the XY plane when we see the things from the top. So we can use the front plane. Now we can see from here that the front plane, the horizontal side is going to be the X, the vertical side is going to be the Y, and that's exactly what we need. So I'm going to start to sketch something. So now, well, that will be my data point for the sketch. And I'm going to work on the part as we remove the material. So I'm going to make a block, and then I'm going to start removing the material step by step to have the final shape. So I will create something. It's actually not from my own brain, because I was sketching that 3 times last week for the student from Western Sydney Uni, and I'm going to repeat it back again here. So the first thing I'm going to do is I'm going to create a block which is going to have 100 millimeter length, 100 millimeter width, and 20 millimeter thickness. So I'm going to go to the 0 point. I usually like to go as close as possible to be sure that when I'm going to put my pencil, this will be the 000 point. Okay, then I'm going to sketch the square as you call it out, and I'm going to do any square. And once again, maybe I'm an old man, or maybe I see it as an easiest way. I don't use the what they call it, the measuring thing. Well, when you select the part and you mention this will be the length, I always going to do it like that. Click on the line and type 100, and it's going to be 100 for the width, and for the height another 100, and we have the block of 100 by 100. Give it a thickness of 20 millimeters by extrude block, and make it 20. And this will be the block. I'm going to start removing the material from, and I'm going to have the final shape.
The problem with
now
doing
again,
that, sir, is that it's undefined.
Yeah, you're right. It's happened like that, and it sometimes, yeah. So before I get to go further, again to say the part, because I don't want to lose it suddenly. You know that the prank that this company want to do with us every time is they restart the software suddenly. So I will go to part 1 tutorial. Okay, we made the block. Now I would like to make some details on the face of this block, and this will be done by, of course, milling operation. So I'm going to click on the face, and I'm going to sketch a circle in the middle. So to sketch a circle in the middle exactly, I must have a center point. To do the center point, I need to sketch a line for construction, either going to be from the center here to the center here, or the center line here to the center line here, or you can make it diagonal. I prefer to do the diagonal one. So I'm going to go to the 000 point here, click a line, and take it to the other side. Now, the center of this line is going to be the center of the circle, and of course, going to be the center of that face. So I'm going to sketch a circle, and the circle here, I usually to be 50-50. Yep. I'm going to make first circle was going to have the diameter of 15 millimeters. So the radius is going to be 7.5. That will be my first circle. Now I'm going to sketch another circle. And this one is going to be 80 millimeters diameter. So again, to make the radius to be 40. Okay, now I have two circles. I'm going to make a ring for this circle. So I'm going to make the offset of the intensities, and I'm going to make the thickness between these two lines to be 5. So 5. That the diameter of the outer circle now is 90 millimeters. Okay, now that's what I got. The circle in the middle is going to be a cylinder. The circle to the outside, two circles, is going to be a ring shape. What I'm going to do is I'm going to take this area between this circle and this circle, and anything outside this circle lower by 2 millimeter depth. So to do that, I'm going to do the cut of the boss. So I'm going to remove this line. I don't want it now. Okay, and I'm going to do the features, extrude cut, and I'm going to select the area I would like to remove. So I'm going to remove these two areas. I don't want it to be down to 20. I only need it to be down to 2. So I'm going to change that to 2. Why it's a 2. Okay, so I'm going to choose this part and that part. Now what you can see by the preview, that these two areas is going to go down, leaving a ring and cylinder in the middle of the face. Okay, now we had that shape. Now in that shape, I'm going to sketch two pockets here. One pocket, a hole, and hole here. And after that, I'm going to show you how to use this block with the solid cam. So I'm going to click on that face. I'm going to sketch a line. I'm going to make this line for construction again, because it's not going to be a part of my sketching. I'm going to sketch a line from 0 and 50 to 0 and 50. I'm going to send you the engineering drawing for this sketch later. Now I'm going to make a ring. If I would like to have a pocket, which is going to be attached to this arc. So instead of sketching the circle, we can do it as simple as that. We just click on the edge here. And then I'm going to do the convert of the intensities. I'm going to have a black line here. Now you can see I got a black line. Well, the third thing I'm going to do is I'm going to click on this line, the line I made, and I'm going to do the offset of the intensities. And I'm going to make it to 7.5. Again, to reverse it to the other side and say, okay, now I have this line. Now this line is contacting with the circle at this point and at that point. That's mean the line after this arc is going to be different. Well, it's going to be separate from this one later. Now, the fourth thing I'm going to do is I'm going to sketch a line, which is going to moving to here by 120 degree from that line. Now, this line is parallel to this one. So I'm going to sketch a line from the center, moving to the by 11 o'clock, which is going to be 120 degree. And I'm going to click on the center, which is going to be 50, 50, and sketch a line randomly. Okay. And I'm going to change the angle of this line to 120 degree, 1, 2, 0. Okay. Now I had this rough shape. From this rough shape, I only want to have 1, 2 lines and part of the arc. So I'm going to trim the intensities that I don't want. So I'm going to trim this part up. Trim intensities. Trim that part. I'm going to trim this part of this circle. I'm going to trim this line. I'm going to trim that line. I'm going to trim this line. Trim this line. I think there's something has been cut it. Yep. So I cut all the parts that I don't want. I just left the part I want, which is going to be this line, that line, and this arc. Now I have the shape of the pocket I want. You can see that the edges we have here are sharp edges, and this cannot be done by the milling operation. So I will do something about it later. Now I have this part and I would like to bring it to the other side. So what I'm going to do is I'm going to select the three part of the pocket I have. And I'm going to do, of course, the mirror of the entities. And it's going to be mirror about this line. And it's going to make it to the other side. Now I have the two pocket shapes on both sides of the line. I'm going to extrude cut for these two pockets, 1 and 2, to the depth of 2 millimeter. Say OK. Now I created the two pockets. Now you remember that the cutting tool in the milling operation is going to have a cylindrical shape. That's means if my cutting tool is going to move here, it's impossible to give me this edge or corner. It's impossible to give me this corner. Well, if you would like to make a part with this shape, it's impossible to do it with the milling operation. Maybe you can do that by approaching operation, approaching where the device is going to go forward and backward and cut the edge using a single tip cutting tool. But for this one, it's impossible to be done by the milling operation. So the milling is always going to be a fillet shape, and the fillet is going to be generated by the cutting tool movement around the corner. So I'm going to change all these edges to a fillet. So I will choose the fillet here. There's the fillet option. Okay, and I'm going to define the fillet diameter to be 5 millimeters. That's what we have in the drawing, and you can see that actually at the end it's going to be something logic. Now the full preview, because this will show me the thing. If I get to use the fillet to be 5 millimeter, that means my cutting tool should have 10 millimeter diameter. So I'm going to choose all these corners and make them as a fillet with 5 millimeter. Oops, no, I should remove that because I clicked the face. So delete the face selection. Go to that and delete, yeah, and use the edge, not the faces. Another edge. And the last one. So the full preview is going to be very useful, especially in one of the examples we used to have. We had 4 pockets. And for the 4 pockets, you're going to lose counting unless you forget to see them. So when they are all yellow, you can say, OK. Now the parts became more logical to be done by using the milling operation because the edges now are fillet. That means the cutting tool will move along this line, stop here, then change direction. So the center of the cutting tool, of course, is going to be offsetting by the value of the radius of the cutting tool. Now, what I'm going to add is a hole here with 10 millimeter diameter and 10 millimeter depth, and another hole here was going to be 10 millimeter diameter and 2 millimeter depth. So I'm going to click on this one first and do the sketch, and I will make the 10 millimeter diameter circle. I'm going to actually make it much easier. Offset of the entities. That's to the outside, 7.5. So I'm going to make it 2.5. And then I'm going to reverse it. I had 10 millimeter diameter circle has been created. Now select the sketch and do the cut of the extrude to 10 millimeter here, 10 millimeter. and I'm going to have a hole with 10 millimeter diameter. Now, we're going to sketch another circle here, and this circle is going to be away from the outer circle of the ring by 15 millimeter, the center of the circle. So if this is going to be from here to the center is 15 millimeter, that means it's going to be only 10 millimeter from the inner one because the offset is 5. So I'm going to sketch here, make a line for construction, go to the edge, find the block, the yellow square, choose that, and move horizontally, and make this line to have 10 millimeters, 10. Say OK. Now, click on that, click on the center, and make the 10 millimeter diameter. So the radius is going to be 5. And done. Now for this circle, I'm going to take it down by 2 millimeter, 2. And that's what we're going to work on this part with the solid cam. Okay, now we have a part. We're going to start doing the solid cam. Now, when I start to remove the material, that's the machining. What will be the case if I made a block or is going to have the 100 by 100, but it's going to be 18 millimeter diameter height, and I start to put the part on it? What will be the operation in that case? It's not going to be a machining. What we're going to call it?
So what was the question?
If I'm going to, instead of sketching the part like that, by making the full block, and I start to remove the material by the extrude cut, that's the machining. Because the machining, we start with big part, we start to remove the material until we have the final shape. What will be the case if I'm going to make the base, then I start to add the shapes on it? So example, I can make square shape.
3D printer.
Like it, yeah. So it's going to be additive manufacturing. I'm going to have the base, then I start to add the ring. I'm going to add this shape in the middle, add the cylinder at the top of each other. So it's going to be like additive manufacturing. Okay, so that's the difference between both. By the way, I need to remind you that we talked about this one earlier in the manufacturing. I get to read back once again here. Usually what we have, if we are going to have a comparison between the machining and the 3D printing. Now, you know that usually everybody now promoting 3D printing as going to be something for the future. And they talk a lot about it. Now, my idea, my point of view as an engineer, and I cannot say I'm a professor in the manufacturing, I'm a professor in innovation. I know various things, but I'm not actually number one in manufacturing. But I can tell you that it's actually overrated. And when you get to talk to people who are especially in 3D printing, it's going to be very easy for you to convince them that it's actually overrated. The time required to do the 3D printing is quite long, too long. That's number one. Number two is that the property of the material is not going to be strong as the one we're going to have from the machining. Longer time properties. What the main properties problem we have is, if you can melt something with a 3D printing machine, that means it's not going to be able to take the high temperature in the real life. For me, I try to use these filament parts for the air conditioning, and it's actually it's semi-melted. It's almost melted when they exposed to the sun or to the little bit higher temperature. So it didn't work. They told me, oh, the metal can do it. In all the cases, we're going to have some porosity for these parts, so they're not going to be 100% good. Maybe 3D printing is a good thing for prototyping, but it's definitely not going to be a very good thing now till now for the application. I think you saw the board that one of the university in the United States made. They 3D printed a big boat hull. You saw this video before? Or the submarine that they said, oh, we're going to make submarine. Now, the problem we're going to have for this part is they're using the polymer filaments, and also it's going to be porous. So how am I going to put a boat in the water while it's going to have porous material that's going to allow the fluid to get in? Anyway, so we made this part, and then I'm going to start using the solid cam, and later we are going to learn how to use it with the NX. I using the solid cam because I've been using this one for a long time. I used to have another thing for the AutoCAD, I forgot its name. And you can see that I'm going to do it because I know how to do it. I will start first with the new, choose a milling operation. You can see that the list actually have mill turn, it's have turning, it's have whatever thing is, depending on the part you're going to make. I just choose the milling operation. And now the software should be preparing the part for me. I hope it didn't, yeah, start now. Now we start to have this new page. It's a new milling part. I'm going to use it external because usually I'm going to have it, well, the only problem I have with the external is that I may have to do it multiple times or may have to call the PRS type once again. If I get to call it as solid part, this will cause a problem when you retry to open the part again. So I'm going to keep it now external, say OK. And by the way, in the advanced manufacturing, when you're going to do the CAD CAM, you have to do a recording for your work like that, how to start choosing the part and how to choose the machining process. Now, the first thing that the software will ask me is to choose the CNC machine I'm going to take my code to. So I'm going to choose, for example, the Fanuc. We used to have the Fanuc 1000. I'm not sure if it's still there. Nope, we don't have it. I think that the machine we already have in the lab is the HAS. So I'm going to use the HAS now. I need to show the stock material. So click on the stock. Ask me here to select which part I would like to do this CAD selection. So I'm going to click on the part. It's going to make a green lines around it. Now the green lines will represent the material I'm going to start with to get the final shape. It's added, as you can see here, 2 millimeter from each sides, but 6 millimeter from the end. So to make it easier for you now, again, to do everything to 0. So 0, tab, 0, tab, tab. In the bottom, I get to make it 0. So you can see that the green light is going to be attached to the part from the side, but it's only going to be available from the top. Say OK. Now, before I'm going to go further and start to do the machining order, I need to define the coordination system. Mainly is going to be the datum point. So I'm going to click on that, and it's going to ask me to define my datum point. The option I have is select face, define, select coordinate system, normal to the current view by 3 points. So I'm going to choose select face. What will be the most important thing for us? Where we are going to have
The center.
the datum. Sorry?
I'm not sure if I'm correct, but I said center.
You can do it on the center, yep. But
bottom right.
Yeah, as we mentioned earlier, it's going to be the bottom to the left at the top face. So the top face of this work part is going to be the highest surface we have, which is going to be this one. So by default, because you said that usually we always prefer to have the datum point at the top lower left corner. So again, to take a look from the part from the top, is going to be at this position. Now, I explained to you earlier why we have it at this position. If I'm going to work on a part like that on a CNC milling machine, on the table, if I would like to hold the part, I'm going to hold it using a vise. The vise have 2 sides. One of them is going to be fixed, the other one is going to be slide. Try to remember the thing. We're always going to have the fixed part in this direction, while the slide jaw is going to be in this direction. If I'm going to put the center to be the datum point, if I'm going to machine another piece of work part is going to have 120. The datum point has been defined for the machine to be here, but the new center is going to be here. So to overcome this problem, just put it just near the fixed part of the jaw. So this will be the point. That was the main reason we always try to put the center of the origin to this corner. So for example, this will be the end of the fixed jaw of the vise. So it's always going to be my reference. So I can fix the part here, and I'm going to be sure that this will be the datum point, and all the machine will be done peacefully. When I say peacefully, that's we're not going to have any contact with the jaw sides. Now I'm going to say OK. Now it's going to go to the next step. I don't need to change everything here. Say OK. 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 So everything has been defined. Go to the next step. We're going to define my part. Now we have some templates here. I was going to use it. Actually, it's going to be much harder to use this one rather than try to do it yourself. You're not going to learn. So I'm going to try to do it myself. Close this one. And that's what we're going to have. The machine has been defined, the stock material, the coordinate system, the target, the updated stock, the tool. We don't have a tool yet. The machining process, geometries, fixtures. Well, actually, some of the advanced work, you can define the fixture, but you actually need to make your own fixture by CAD model and put it here. I'm not going to do it right now. We can do the clamping, and you can select the clamping from the files and bring it to the software. Another thing I'm going to show you later. Now we need a tool. We need a tool to do the work. To make the tool, we go into the tool selection, right click, sorry, part tool table. So I'm going to make a new tool because the table is empty. Click on add. So these are the most common types of the milling tools. The end mill, this one, is going to have a flat head and cylindrical shape, normal cylindrical shape. This one can cut the pockets, can do the drilling, can cut from these sides if again to be attached to here. And this is similar to the most of the example we worked on. Now, the nose ball is not going to give you a sharp corners vertically. It's going to make it a little bit rounded. I think you remember why we needed sometime a little bit rounded, because this will give it more strength rather than the sharp corners, edges. And we have the ball nose like that, or the lollipop, and this is going to be able to make the contour shapes. If I can try to make a contour shape with the end mill, I mean on the X, Z plane or the YZ plane, or spherical shapes, we're always going to use the ball nose or the lollipop. Other times, the face milling to remove the material from the face at higher rate. We have the dovetail mill, which is going to cut the slots. And we have also the T-slot cutter. We have the taper mill, from the name is have a taper ball nose, the slot mill, the engraving. We had the chamfer mill. We had the threaded mill. Now this cut the thread from the inside and the outside. You can have a threaded mill, and we have the threaded taper. We have the barrel shape. We have the oval form. Others, which are going to be for the drilling, mainly for the drilling, we have the center drill. We have the spoiler drill. We have the normal drill. We have the tab. The tab actually is going to be just in generating the internal thread for the small holes. We had the reamer, which is going to give you the correct diameter for the surface for the hole by removing the material at very small amount. We have the bore cutter, which is going to increase the diameter of the existing hole. Another thing you'll need to learn how to use it in the metrology lab. We are going to have as an assignment number 2 for this subject, which is the CMM machine. Is going to check the distance between 2 lines, or the thickness of a part, or for example, the diameter of the circle. I'm going to teach you how to use this one in actual life, and you'll need to find your way on the SolidCAM. We have the projection tool. Now, the projection, as I mentioned, is going to be the tool that able to cut the sharp corners in the on the part. This cutting tool is going to just going forward and backward multiple times and cutting the edge as a sharp edge. And we have the normal saw. Now for us, I'm going to use the end miller as a cutting tool. They are going to define the diameter, and this will be 10. You can see that this will be diameter. And many things are going to be changed with it as well, which is going to be, for example, the ST here and the AD. So I'm going to change this one to 10. The others will be changed automatically. I'm going to change the AD to 12, though it's not going to be much different, but I will change this one to 12. This is not going to change the others because the AD usual is going to be a little bit larger. Now for the length, the maximum depth I have is going to be 10 millimeters. So the CL should be minimum 10 millimeters. So I will check for the CL here. It's 24. So this is going to be okay. So I don't want it. I'm going to save my first cutting tool. I can add another cutting tool. I will choose the ball nose. I'm not going to use it, but I'm going to choose it now. Again, I'm going to make it, usually the smaller, it can give you more spherical shape. The smaller nose ball can give you a better spherical shape. So once again, we can change everything here, and then we can save it and go. Actually, I can do save and exit. So save and exit, I'm going to leave this list. Now we have 2 tools in the list. Now I'm going to remove the material as the way I did when I was sketching the part. So I'm going to remove the material here and the material here to the depth of 2 millimeters. So I will go to the operations and go to the setup, left click, and I'm going to add milling operation. It's a 3D milling operation. So I'm going to click on 3D milling operation. I'm going to come to this page first. I need to define the geometry I'm going to cut. So I'm going to define working area. I'm going to define the working area, select, and what I'm going to remove is going to be anything between this one. So actually say, okay, you can see that I generated a purple line. So anything between this line and this square should be removed. So I made the first chain. So my cutting tool will remove the material here. I will say, okay, for safety, I'm not going to join both operations together. I will say, okay. Now the tool, select the tool, the 10 millimeter diameter tool. Say, okay. The levels. Now the upper level, click on it. This will be my upper level, 0. Say, okay. The lower level by default is -20. I'm going to choose this surface to do the minimum level or lower level, which is going to be -2. Say okay. Now the technology we're going to use for the rough, I'm going to use the hatch. Now I'm going to click on that. It's going to show me that this is the hatch operation. Another thing, the contour. The contour, as you can see, is not going to go outside the square. The hatch, it will leave, the cutting tool will leave and come back. Okay, now that's the main difference between the contour and the hatch. I will try both of them. We can do the plugging, which is going to be like that. This is usually going to be done only if you're going to do the face milling. So I'm going to go with the hatch now. For the overlap, take a look to the overlap. What do you mean by overlap? So the next path of the cutting is going to be overlapping the first one. So this will prevent of having any edges left on between the 2 cuts. So I'm going to have the overlap, which is going to be something about 0.5 millimeter. Clean flat. Clean flat during the roughing or after the roughing. I'm going to do it during the roughing. The wall offset is 0.5 and leave everything as it is. Now I'm going to save and exit this operation. Now let's show you what's happening here. So if I'm going to do the left click, I will calculate the movement of the cutting tool. So you can see this will be the movement of the hatch cutting tool. It will start from here, and it's going to go forward and backward to do the cut. Now let's check what will be the case if I'm going to use the other thing, which is going to be the contour. Save and exit. I'm going to recalculate that. So this will be the contour movement. The contour cutting is what we learned. Okay. Now I'm going to go now to do the cutting inside. So I'm going to right click and I'm going to insert adding a new milling operation, 3D milling, and the process is going to be the same, define. And I'm going to define the working area, define the working area. And now the working area is going to be between this ring and this ring. So anything between them is going to be removed to the depth of 2 millimeters. So we define that. The tool is going to be the same. The level is going to be upper is 0, lower is -2. And the technology, I'm going to use the contour again. So it's going to go in circles, circles, circles. I'm going to clean during the roughing operation and save and exit. Now, this will be the cutting tool movement when we do the work. So it's going to go in circles, circles, circles. Actually, you can write down the code for this part, by the way, because we learned something much harder than that. And then we're going to apply for the assignment number 1. It's going to be much, much harder than that. Now I'm going to add the operation to cut the pockets. Now, when you are going to cut the pockets, I'm going to right click, and instead of that add operation, I have the pocket. So I'm going to choose the pocket directly. Pocket. Now, in the pocket, you can see that the list has been changed a little bit. So I'm going to do the following. I'm going to choose the geometry. And do I do it like that? Yep. So this will be the chain number 1. This will be chain number 2. And say enter. Now I will go for the tool. The same tool can do the job. Because you remember that the diameter, the radius we have for the fillet was 5. Now the levels. The upper level is this one, -2, and the pocket level is 2. But once again, it's going to be good to double check. So it's going to be -4, and the depth is going to be due by calculation. Now, why I started with the upper level to be -2? I don't want the cutting tool to move in the air without doing any work. Now, the technology we're going to use is going to be contour again. The rest of the material of the chamfer, I will leave it none. The offset, I will leave it as 0. The finish, I will leave it as do finish for both. Number of the pass to be 1. Okay, now we have everything. That's the advanced thing I don't want you to play with right now. And we have the flow of offset is not correct of finish. Okay, let's see what's happening now. Yep. Now let's see what will be the movement of the cutting tool. Now I'm going to hide these 2 cuts just to show you how it's going to be. So it's going to go for the center and start to expand to the outside until I get to have the final shape. Now the only operation left is drilling of these two holes. So again, to make them separate, because you can see that the depth is different. So set up insert milling operation is going to be drilling. And once again, I'm going to choose, I only need to choose what to drill. So if I'm going to click on this edge here, you can see it's showing me the center. And the depth of the center is the 10 millimeter diameter. Say OK. And now the tool is going to be the same one, because you remember that this drill was flat. So I'm going to choose the same cutting tool. And
could you use the mill for that?
Can you use what? Sorry?
Can you use the milling tool for that hole?
Yeah, because it had a flat surface at the end. I will show you that again. Just give me 1 second. Now for the level, the drill depth, now we need to define that. So I'm going to click on that. It's going to be -10. Okay, now, oh, well, yeah, it's done already. So I'm going to show you that soon. Okay, now you can see that the bottom is a flat, is not table shape. So we can use the milling tool to do the drilling in this case. If not, you should choose your drilling tip as one of the tools. Now the second hole, same operation exactly. Do the drilling, and we're going to, well, you can see that if we would like, if we're going to have such shape, we should choose the drilling tip instead of the milling tool. Now, once again, I'm going to click on that, the edge, the bottom. Did I choose the bottom one? Yep. Say OK. The tool is going to be the same. And the level is going to be that level, -4. Say OK. And save and exit. Now, we had everything ready. I can simply right-click on here and do the calculate of all. So it's going to be done step by step. So the first step starts from this point, the second one here, third one here, the fourth here. Well, actually, third and fourth is going to be the same. Then drilling this one and coming to here. Now, the good thing with the solid CAM, it can show us a simulation of the process. If I'm going to right-click and do simulate, it's going to give me multiple options. I can see it as 2D, 3D, solid, verify, rest of the material, and so on. So again, to show you before the operation, after the operation, and the 2D, see the things as we learned to write. Let's give me this one, like that, as we learned to write it. Okay. Oh, by the way, we are able to select what will be depth of the cut for each step. But now it has been done automatically because the depth are just 2 millimeter each time. 3D, we're going to see it as 3D. We can see the tool moving. Again, to make it a little bit slower. Actually, it's too slow. Should speed a little bit. Okay, so what else do we have? So it's verified. Yep. Okay, what do we have next? The host CAD. That's without showing the cutting tool. It's on the CAD model itself. Okay, what else do we have? Well, machine simulation. Now, that's a problem, which is my weakness. let's check this. So this one first. We saw this one. The machine simulation. The machines for simulation is not defined. We should do okay. Well, let's start here. Yep. I think that we can do something from here, and we can show the machine operation. Add operation one template, not like that. Fixture. Yeah, I remember it was from here. Show. I have to remember how we used to do it. Yeah, actually you can do the same process from here, but I always prefer to do it from here. Okay, now we had everything has been defined, and it's going to be okay. Now another way we can do the milling operation, the turning operation with this process as well. The tutorial I made, not for sketching all the part, only for doing all the CAD CAM. You are going to have 3 parts in the assignment number 1. You need to do the CAD CAM for them using this operation. And I will ask you to do it with the solid CAM and the NX. I mean, for example, you can choose one of the part to be with the solid CAM, the other one with the NX, and the other one with the solid CAM. It's up to you. But in all the cases, you need to record a tutorial like that with your voice for 2 of the parts. Now, why I'm doing that? This will be a proof that you did the work. It's better than writing something or taking snapshots for all the steps. The best thing is do recording for that and upload the thing to YouTube and add the link to your assignment paper. Later, I'm going to show you how to use something like that. It's called the numbers. Yeah, the numbers, which is a screen shoot software. Is it free for most of the time? But I actually doing the I pay money for that because I'm using that heavily for recording. And you can simply record the video starting with the desktop or using the tab of one of the tabs here, or using the webcam only. It's very good. It's recording the sound, doing the drawings. You can write down on your video. So it's something like the Photoshop, but it's lighter and it's an app with the Chrome. I will ask you to do to download this one to your Chrome and recording the sessions like the one we do right now. Okay, so I think that a new experience.
Can you
for
upload
everyone.
that file to Teams, sir?
Yeah, sure. Again, to oh yeah. So what did I save it? Just give me 1 second. File save as it's on. And now it's on temporary, but I'm going to put it on OneDrive UTS. Yep, I'm going to put it here. And then I'm going to find it because I UTS OneDrive. It should be here now, right? The part tutorial. This one, right? Yep. I'm going to put it now on Teams in front of you because we're working on the same screen. If I'm going to drag it and drop it, it's going to be uploaded directly. What do you think? No, it's not connected here. Oh yeah, it's came. Still loading. Okay. You got it?
Yeah, perfect.
Great. Okay, so you can do the same thing. I prefer that you try to do the same thing today. I mean, if you are going to have the software working, you can do the work on it. Actually, for the NX, which is this software, I had used it for a while, but I was playing with it 2 weeks ago. And the process is not that hard. You can watch 2 main videos and learn how to do it. And also, again, to upload some hands out on Teams. and on the website, on the canvas, on using the annex. Actually, this one is very good hands-out. I found it online, and I think I'm going to make it as a video, short videos, to show you how to start to do the work and how to do this simulation for them, as we did with the SolidWorks, because this one they said is very popular in the industry. I don't know the university saying that. So you can see that's what we can have new. You can have model assembly, shape studio, sheet metal, the routing logical, the routing mechanical, electrical, blank, whatever thing is. So I'm going to start with the model, and we're only going to try. Oh, let us try to do something. Do you think that this will import the parts from of the SolidWorks, or maybe we need to save it as a different thing? Oh, wait. Oh, that's bad. I should define the connection of this software with the
Change file types though.
No, yeah, I will change the file type, but I'm talking about now. I should,
yeah.
Yeah, I should link that to the, yeah, it's actually, it should be connected to the OneDrive. Anyway, doesn't matter. Okay, so I will leave that now. I'm going to think about it later. Yeah, so we can actually make a new model. I think it's going to be something like, you can see, by the way, what we can do here. We have manufacturing, we have the chip structure, additive manufacturing, machine line planner. All these things are going to be required by the students to define themselves later when we're going to do the major project. So as I told you once again, it's something like you driving always on the left-hand side of the road, then you have to change to the other side of the road. But the concept is at the end is going to be just driving. You're just driving, so shouldn't be a big issue. So let's try to make the same part here. We are going to make it on the XY plane. So let's take a look on that. I hope I will be able to do it. I know it's going to be a quite challenge. It's going to work like this way. So let's say here, existing point, origin point. I try to sketch. I should do it by sketch. Sketch. It's uploading. Yep. And now we are going to start to sketch the thing. Yep. So it's something like the SolidWorks. Oh, I should leave that now. Say okay. And I'm going to change the line, choose the line. I remember there was somewhere where you can type what the length required for this line. Yeah, it's like that. So you choose what will be the length you're going to have here. Okay. But definitely there's a way to type the things like what we have with this with the AutoCAD.
Maybe it's rapid dimension. Same thing as smart dimension.
Yeah, actually, I should change that before again to press OK. Show me here. Actually, the dimension is here, but I should double click on it and change it automatically. As I told you, it's something like what we do with the AutoCAD. Because I'm not going to do it like that. It's going to take the whole day. Anyway, let's keep it trying. I just remembered why I left this software. Because you know that the SolidWorks for most of us is can be something like a video game. It's very easy to play with. It's user friendly, unlike the other softwares. Some people still like this. So, sorry, the AutoCAD. Well, usually what I'm done last time is I just delete the thing and start again. Anyway, again, to do the extrude for that, and again, to make it as 20 millimeters, still uploading. I don't know why it's taking that time. Yep, I can see this. Yeah. Okay. Now it's at the 25. Again, to make it as 20. And right click, say, okay. Now we have the block. And then we're going to do the same thing by going to the top face. Oh yeah, I think we should choose that like this way. Choose as a dead home and say apply. So this will be the plane again to work in. To sketch, make a line, and I forgot how to make it as well. Once again, just to remind you that I just try to find my way to remember how to use this line. Set end point, start point, and again to change here. Oh yeah, so we need to change that before we're going to left click to get the exact length. Anyway, for this one, obviously I can see that this will be the end point, and we got the end point extrusion. Yeah, so I made the line, and now this line is going to have a center, and this center is going to be for the circle, and I'm going to make a circle here. Once again, I show you how to use this one now because we're going to use it in our next semester a lot. The school want us to do it. Midpoint, and the diameter was 15, because this is diameter, not radius, not like this all work. Arc center. Yeah, I should choose. I choose another circle each time. Yeah, this one is going to be 80. Okay. Now to check where's the offset here. Should be one of these things. Anyway, I'll try to do it myself. So I'm going to sketch another circle, which is going to have 90. Actually, I need to learn how to do that once again. Okay, so now I'm going to choose this line and delete it. I don't need it anymore. And now we should have the extrude cut. Now this one says hole, but I'm sure that we should have something like the extrude cut. Yeah, I remember these things, but it's something like coming back from the old days. Anyway, I'll try to do something. Okay, extrude, and I think we can select this to be minus, so it's going to be minus 2 millimeters. I can select the sides. Yeah, I'm going to stop here. I'm going to try to refresh my memory on that and come back to you later. Anyway, so I hate to say, but it might be like, yeah, I know. You like this all work. We like this all work, but the story with this software is very funny. And I'm going to say it by recording anyway. So I'm going to turn off the recording, then we're going to start talk about this one.